Our internet, y'all, right? Oh, it was much faster than first period. Okay, so you guys had, and I'll do the opener in just a second. Y'all had an assignment yesterday on calorimetry, and I'm sorry, y'all, the freaking horse apples are making me all kinds of messed up right now. If I start turning red, it's not my fault. Apparently, that's what happens. Okay. I am hopefully going to be able to grade these two while y'all are doing the Google assignment, the Google Slides, whatever you call it. But this one from yesterday on calorimetry, that's the one you should be able to turn in today. And some of you did. I got one from George. What? The ones that can be turned in are potential energy diagrams, and then it's so these two. Do I have graded yet? These two. And then obviously, and they can't see me holding this up. This one from yesterday. It just was so bad. Ugh. But everything is online today. Oh, who's that? Oh. Well, I told it to accept, and I don't understand. Anyways, let me do real quick official attendance. You went to the bathroom. Ailey's here. Tiffany's not here. Okay. Sebastian, Caitlin. Braden's not here. Hold on. I'm going as fast as I can and we'll get started. But yes, everything is in Canvas today. Okay, so yeah, and that's, I guess I can put it back up on the board. Or I can put it, hold on to it for a second. Wait, is the other one done? Okay, hold on to it for just a second, and I'll go back over it one more time because there's only 2 things on the test Tuesday. It's those, how to read those graphs, and then the calorimetry stuff, the Q equals MC delta T, that. Alexis. Okay, Veronica did come in. Who else? I'm so sorry. Let me finish attendance real quick. Anna's here. Aiden's not. Valerie's here. Reagan. Braden's not. Jeremiah's not. Jimmy Kyle. Okay. So let me sort of run over what today's is. And then if you have problems with either the calorimetry, I hate horse apples. I didn't know I was allergic to horse apples. But I'll go over if we have generic questions on calorimetry and those potential energy diagrams, because that's all that's on your test. I don't want to erase my glucose molecule. I'll do it. Nobody else online. Okay. So for the opener, and as far as grades are concerned, since we are at progress report time, for y'all, it's your, I haven't graded them yet. Okay, but this one is going to go into the parent portal for progress report. This one is going to go in, and then also well, I haven't. Okay, well, I got your first potential energy diagram. I got one from George, Jimmy. Okay, and then the second one I got from George, Tiffany, Braden, Valerie, and Jimmy. Okay, so that's the one that I don't have for you. Okay, and then also, calorimetry. I meant to have this graded, but I had to go get cough drops from here. This is nuts. And then also the one on calorimetry, I'm going to have into the system also. Now, if you turned it on like Canvas or in on Canvas, I haven't had a chance to grade them yet. I wanted to do it today and I didn't get to it. I'm also going to put in your openers. So 4 more daily grades. All right, so for today, why does it not, okay, so the stuff we did yesterday, this thing, board space, which I know I left off the P, but it doesn't really matter. Why does it not matter if your change in temperature is Celsius or Kelvin? Why doesn't it matter? It mattered in gas laws. Why does it not matter on this? I don't think I did what I did with 8th period with you guys. Okay, I'll just redraw through this. Okay, so you guys know, how do you switch from Celsius to Kelvin? What do you do? Right, back and forth is plus or minus 273. So let's say we go from 10 degrees Celsius to 40 degrees Celsius. When you subtract them, what's the difference? What is 40 minus 10? Okay. Okay, so I'm going to switch this to Kelvin. So I'm going to add 273. And what's 313 minus 283? This is why it does not matter which temperature scale you're in, because you're adding the same value to Celsius. So they're all like 1 degree Celsius to 2 degrees Celsius, which is a 1 degree change. It's the same thing as 273 to, or no, 274 to 275. It's the same jump. It's the same, when you subtract, it's the same difference. So because when we did gas laws, you had to be in Kelvin. If you didn't put it in Kelvin, it didn't work. But with this particular thing, to solve for heat, the specific heat equation, it doesn't matter. Now, they both have to be Celsius or they both have to be Kelvin, or you've got to like switch one to the other, which I've never done to a student ever. I don't even remember seeing that in college, which would be where they would try to get you. So what you guys do have for today, and then I'm going to come back because I'm going to have questions about the diagrams, and I'm sure I've got questions about the formula, is this Google slide. And I know that I can't I can't do anything with this when it's in this particular presentation. But the first one, which Latin Greek root prefix to their meaning. Hopefully we know what exo and endo mean because they're opposites, and thermo or therm, you're just putting it into the right place. And then you're going to categorize things if they are endothermic, if they are requiring, oh, wait, am I telling you an answer? No. Are you requiring energy to make it work? Or are you letting energy go back to the environment to make it do work? Okay, so let me erase this. And I know I've got questions about these diagrams because I don't like the way that this is wrong. You've got essentially these diagrams. Which has the bigger uphill slope, endo or exo? Endo, okay? If you have to put energy into a system, you're having to climb the hill. And if it helps to think of it as a roller coaster, awesome. So an endothermic is going to have a reactant. It's going to have an increase, an activation, and it's going to have products. In an exo, it gives off heat. So you're still going to have reactants. You're still going to have an activation energy, but then it's going to give off energy to make its products. I know my drawing best, but whatever. I meant to put the expos. Dang it. My orange is almost dead. And I'm sorry, all these horse apples are killing me. Now, let me go ahead and do this one because I know that we have questions over here. So you're going to have a potential energy of your reactants. These are your reactants. These are your products. Okay, your potential energy is from nothing, which is 0. And I think the numbers I used, I think it was 10 here. And then you're going to have, yes, that's yours. You're lucky that people are honest. And then your potential energy of the products is from the right-hand sideline. And I know those of you that are online can't see what I'm drawing on the board, sorry. But the difference between these, and let's say, okay, so if that's 10, let's say this is 30. So when you subtract that value, that's your potential energy of your products. Your potential energy, now this is your you have to hit the really unstable state before you can switch from one to the other. And so it's going to have a potential energy. This is your potential energy of your activated complex. Now, your heat. I don't know why I put this in here. I would never have found that. Your heat energy. Let's see, your. What do I want to do next? Do I want to do heat energy or do I want to do active? Let's do activation energy. So your amount of energy, so let's call this 40, even though it's not perfect, sorry. It's the amount of energy that it's needed to start making products from where you started from. So this is your activation energy, which is what EA stands for. I need to invest in expos. What am I forgetting? Delta H? Yeah, we're in delta H. And so my delta H, which is the heat of the reaction, is from your products to your reactants. Okay, in a endothermic, you have to go up. So this is positive. Okay, I'm about to do this all for, this is endothermic. Okay, so on this side, let's say this is what, 30, this is 40, this was 10, this is 0. I know it's not perfect, but what happens when I draw on the board? So on an exothermic, I wish that camera could record over here, but it just doesn't work. Your potential energy of your reactants is from the reactants to 0. Your potential energy of the product is from its line down to 0. Your potential energy of your activated complex is from the hump down to 0. EEA. And then your activation energy is going to be much smaller than an exothermic. It's the hump down to the reactant. I'm not forgetting. And then your change in heat, because you are going from a higher to a lower, will be negative. It's the only thing that's negative. Because being able to read these diagrams is basically half your test. And we'll review for the test on Monday. The test will be Tuesday. The other half of the test is calorimetry, which is what we did yesterday. Let's see what else is on this puppy. This. Okay, so my gosh, I wish I had more board space. Now look at down here. So the formula is Q equals M. Let's see. Technically, it's supposed to have a P. A lot of times I'll leave it off. And your Q is heat. It's either in joules or calories. I don't know which one it is. Is it metric or not? This is your mass, which is in grams. This is your specific heat. Now, this has two different units. It's either a calorie per gram degrees Celsius, but could be Kelvin. Like I said, doesn't matter. Celsius, Kelvin on this does not matter. Or it's going to be a joule per gram degree Celsius or Kelvin, does not matter. And then this last one is your change in temperature, which is your final minus your initial, which can be in Celsius or Kelvin. It does not matter which one it is for this. I know with gas laws, we have a constant can be in Kelvin. Now, when you're using the one from yesterday, when you use this chart, and if you've not done this, pay attention if your calories or your joules, because otherwise this doesn't work. And then the last thing that we did for conversion factors is the fact that 1 calorie is 4.18 joules, and that's how you go. It's not great. I need more sleep. This is what your test is about, with all the extra vocabulary thrown on top. So this was that. Units is that. Solving problems. That's it. So I know some of you are trying to get caught up. Ooh, you guys can see my screen. That's not good. Give me just a second. I'm putting this back on the right slide. These principals walking here and stuff. I'm gonna freeze it. Some of you I know have questions, and I'm about to be able to help you. I gotta stop my recording.